Test. Thank you very much for coming. My name is Sergey Polzunov, and I'm a founder of the company called Blackstork. And I want to share with you the thinking behind implementation of a solution for a specific use case, which is report production. And I want to thank you, David, for kicking off our small train of AI talks this afternoon. It's really nicely bundled together. I will try to follow up his meme-filled presentation with refreshingly black and white one. Effective reporting is difficult. I'm sure a lot of you know that and feel it on a daily basis, how difficult it is to communicate with other stakeholders. And being in the workshop yesterday about CTI and risk, shout out to the workshop organizer, that was great. I heard again and again that the clear communication is the key. We need to understand each other. We need to make sure that the lines of communication are established and they're clear and everybody is able to express themselves. And I think we've been struggling there. We've been struggling building it up and really improving the practice. And I have a feeling that it's because we don't have a good technical approach to it. It reminds me a bit of the like infrastructure management world. Remember when it was pets and not cattle, and then we moved from pets to managing cattle, like systems and hosts and networks. So we started using Ansible, Puppet, Terraform, and engineers were able to focus on important things, not how to manage one specific host, but how to achieve reliability, achieve uptime, and they were able to put their effort into achieving important goals. So I have a feeling that with reporting, we are somewhere in the early days of that. So and this work is attempt to move there, try to figure out the stack. And I'm sure a lot of you will recognize these requirements that we have for efficient reporting. Me, myself, I'm not involved in operations that much. I'm coming from a software engineering background, but I've been working with practitioners for the last 7 years in cybersecurity and figuring out the tooling and software to ease the life of analysts, not just CTI analysts, analysts in SOCs, in incident response teams. And all of those teams has pressure to produce high-quality reports, reports of certain level of quality that is stable. So it's not like you have one family of reports that are good and other that are bad or ad hoc, but that are of good quality, that are timely. For example, like incident response timeline updates need to go out on a regular basis. And the most difficult problem of them all, in my opinion, is customization, because a lot of different stakeholders need to be kept up to date. Often the same input data translates into a bunch of reports. One goes to executives, it's a summary, it's a briefing. Another one goes to your fellow practitioners, and it needs to have IOC table at the end, or Stixview bundle attached if you're on top of your game. There are challenges with all of these requirements. With efficiency, there are in-depth research reports. Those often enjoy the good budget, good time budget. You can spend a month, or a team can spend a month or weeks to dive deep into the thing, to write it down, to format it, to make it beautiful. These are quarterly reports or reports about specific activities. I'm not talking about those. I'm talking about the reports that are often ad hoc, or they are required from your team, but you allocate just a bunch of time on Friday, 2 hours, and then that job falls on a junior analyst that copy-pastes stuff and produces CV overview, or a weekly report, or some other activity report from your team. What makes it more painful is that reporting features in security platforms are often suboptimal. Either it's just a form, text area form, or, for example, CTI Blueprints editor, right, which is amazing structured form, but it's just one web page with text area forms. Or sometimes you have what you see is what you get editor, and good luck. Sometimes you cannot even insert images on tables. I'm not even talking about dynamic content or graphs, something that we can insert into HTML quite easily. The quality is also difficult. I've seen teams inventing the guideline for themselves. They would write down the stylistic guideline, formatting guidelines. They would prepare templates for different types of reports. And they would store them in the third-party tools that are often not suitable for managing templates. Kudos to you if you use Git for that, with the history of changes and ease of collaboration. But quite often it's Google Docs, OneDrive, or even just a Word document that get bounced over in the email. And what's even more difficult is that there are no built-in checks for the quality. It is up to Analyst to put the values in the template, to copy-paste the blocks. There's nothing that checks automatically that all data points are included in the template, or that stylistic and formatting constraints are applied to the report. And then we come to customization, where all of this gets worse because now you have a couple of versions to produce. And you either start from scratch, you describe the same thing in different words, shorter, longer, or you copy-paste templates, different templates, blocks into one Frankenstein monster, or you copy-paste the paragraph of the text that you already wrote. Either way, it's more of a chore than enjoyable work, and it's not really, it's not that fun to do. So it seems like that's a prime target for automation, so we can try doing that. For efficiency, we can ask computers to create reports for us. That's solved. For quality and customization, we need to take a step back, and we need to move away from, we understand what reports are and move away from static templates, which are rigid artifacts, into more of a code-based approach. So we can introduce a custom declarative domain-specific language that describes report as a tree. And that tree is all the branches in the tree. They know what data they need. And the tree describes the full version of the report. For example, one head of the branch can say, I will be talking about the threat actor. And then the children can be, maybe this is associated campaigns, and then associated victims, associated TTPs. And then having this report description and input data and configuration, where you can define how detailed the report can be. You can have the compilation step where you combine all these three inputs and you produce a final report. It can be a small briefing. It can be full description with all the data that you could pull from your data source. And that makes it easier to argue about and easier to evolve as well. A disclaimer here that full automation in our industry is not possible, I think, because there's always somebody who needs to sign off on the final product. You might get away with it for smaller reports, maybe like CV overviews, but on something more significant, there's always somebody who needs to look through it and say, yes, it's good to go. So where is AI in here? How can we use that in any way? I think we need to step away a bit from the overheated term AI and really define what that means. So we can define two different approaches. One is symbolic AI from 60s, 70s, 80s, which is rule-based systems with predefined logic that encoded human knowledge in code. They were used in the domains with a very explicit and well-structured tasks. There is no possibility of learning, and it required clean input and produces very clean, predictable output. And then there are machine learning models. Those are excel at detecting patterns in data, producing creative text, as we saw in the last 2 years, But they require a ton of input data, and the output is less predictable. So I think that will be the last slide where I use AI, and we're going to use machine learning from now on. The fair question is, why just not throw LLM at it? Just ask it to write reports. And it's very tempting, because integration is so easy. I think David showed how easy it is to hook into the API and just send it text and say, write me a report. There are a couple of problems there, is that if we do that, if we use LLM as an end-to-end solution, we rely on it to perform two functions. One is act as a knowledge database with all its biases and over-reliance on training data. And another function is a comprehension engine, where we rely on the model to understand our instructions, to understand our input data. And the biggest problem here is that all of this will happen in a black box. There is no transparency, no auditability, and no explainability of the process. With cybersecurity becoming a bit more regulated in Europe, that's a problem. And it also hinders the production deployments. As a software engineer, I honestly not sure how I would deploy like AI or AI integration into production, because I cannot QA it easily. So end-to-end solutions are very tricky. Maybe we can take a step back and look at the solution from a symbolic AI world. And this is the pipeline that was proposed, pipeline configuration that was proposed somewhere in 1970s, last century. And it defines 3 steps. It converts input data into text. And those steps take the data. In the first step, we take the data. We filter out the data that we really want to talk about. Then we choose what properties of the data we're going to combine together in paragraph, let's say, or blocks of text. Which of them go together. And then the last step, we collapse that definition into human language, into English, for example, or some other language. And we figure out the exact sentences. For the last step, we usually would use libraries, like simple NLG or grammatical framework, that capture the English language in code. So to give you an example, for example, here, if we have CTI Stixview bundle about the threat actor and TTPs, campaigns, and victims, in the first step, we would look at our report template, what kind of data it needs, choose the information about the actor and associated campaigns, for example. Then, in the microplanar phase, we will choose specific data points from that objects. We would be talking about created by, who created the threat actor entity, who first published the information, its aliases, and then about the campaign we will talk about when it was first seen. And then the last step, we collapse it into text, and that will have a description there. It's clear that some of this is inefficient these days. For example, capturing English in code is a bit it's a bit tricky. There are solutions that do that, but managing that is tricky. Evolving that is tricky. And we can have machine learning do that, right? So we might try to use machine learning for the last step. This is a narrow scope for machine learning, so it allows us to use smaller models. We don't need to hook into big LLMs. We can use something very specific, like recursive neural nets that are designed to do data to text or graph to text. Or we can use pre-trained models. For example, BART language model, which these days probably is not considered large anymore. It has 400 million parameters, which can be fine-tuned or tweaked. And it's very well at doing its job converting instructions or text into ordered tokens, into phrases. So in this context, we're going to be using only the English language, that knowledge of English language captured in the model. We're not relying on the textual data, and we barely rely on comprehension. It's just translation of a specific pattern, transformation, of specific pattern into English text. We can use LLMs here as well, but it will be very constrained use, which allows us more control. So the editing step, the last step of that pipeline, when somebody needs to verify the content and sign off on it, can be very short, because we can prove that we talked about all the data points that we wanted to talk about. And it's all structured in the way that we intended, because we only work on a sentence level. If we feel brave, we can go a bit wider and try to replicate 2 of those steps with machine learning. And that's what you often see these days in the security vendor platforms when you have the AI feature. It's not AI assistant feature, but it's more like summarization feature. Sometimes they would present you with like a bunch of alerts, let's say, or a bunch of indicators, and then there will be a blob of text that would say, explain it in a human language. That's a summarization feature of it. So in this application, we're relying on the model to understand our input. It's limited input, but understand an input and describe it or summarize it. We're giving up a bit of control. It's more difficult to impose the constraints on the output. And the result is less predictable. So that last editing step becomes slightly bigger, because suddenly now we need to verify that all the data points that we meant to be in the report are there. So we need to verify that. And if we take it to the next level, we can throw all of them at it. And then we will lose even more control. And we have the highest risk. And the editing step becomes the biggest one, because now we need to read through the whole thing and check all data points and make sure that the model expressed what we meant it to express. So I would encourage you to think about what is the right amount of machine learning in your pipeline. Are you willing to give up control but get more creativity maybe and ease of integration? Or you would prefer a stricter, more rule-based approach and then have a lot of control over your end product? And I think the best solution is somewhere in between. You should be able to configure that per use case, right? So for example, maybe a briefing for the executive team, which is half a page, can be easily generated by a machine learning model. It's easy to edit, it's easy to read through it. It can really detect or make a decision about which data points are important and describe those. But if it's a report about the activity with IOCs, you need to describe TTPs, you need to link MITRE ATT&CK, TTP IDs, etc. Maybe in this case, machine learning model will not do a great job. Maybe then you need to combine it with the rule-based approach and have a better solution for that. So in conclusion, a few points. I think before you jump into new tech, take a moment to reevaluate the old tech, because there might be a good solution that will fit your use case. And those solutions can be married very well with also a classic at this point, classic machine learning models that were released 4 years ago. They can be combined in a nice way to satisfy your use case. And it's easier to deploy. It's cheaper to deploy. You can deploy it on-prem. It's much easier to argue about, because there's a lot of research, there is a lot of expertise around dealing with those smaller models. If you use LLMs, be careful. There are, David raised again the solutions about, the concerns about data privacy. I think there are some efforts happening right now to tackle that. I think Microsoft Azure, there's some guarantees that there is like enterprise access to LLM that it protects your data. So like vendors try to figure it out, but still it's a black box. It's still the integration with a black box that does something and produces content that it's very tricky to QA and verify. And the last, keep in mind on your reporting, be on top of your reporting game. regulations in Europe, NIS2 is coming next year, and it has a duty to report with some very strict timeframes. So we need to make sure that we are on top of our communications with other stakeholders. And with that, thank you very much. I would love to hear your feedback and your experience using some of this tech in your production environments. Also because all of this is pretty new and raw. I finished implementing MVP for that only recently, so I would really appreciate any feedback and your experiences. And thank you very much.
Thank you very much. Any questions? So we have plenty of time to ask questions. Just line up or raise your hand. Nothing? All right, then thank you again, Sergey.
Thank you very much.
And